This video will cover the Geometry Common Core exam from June 2015, questions 22 through 25. Number 22 says that the line 3y equals negative 2x plus 8 is transformed by a dilation centered at the origin. Which linear equation could be its image? If we dilate a line, we know that we have the same slope, but the y-intercept changes by scale factor. So first I should get this equation into y equals. So I have 3y equals negative 2x plus 8. Divide by 3 on all parts in order to get it into y equals. Y equals negative 2/3 x plus 8/3. So if I'm thinking about the slope, I need to find an equation that has a slope of negative 2/3. So now unfortunately we have to do a little bit of work to each problem or each equation in the solutions. So I'm going to work to get each equation equal to y, or in y equals form. So I'm going to start by subtracting 2x in choice 1. So now I have 3y equals negative 2x plus 5. Divide by 3 on all parts. So now I get y equals negative 2/3 x plus 5/3. Now they didn't tell us the scale factor of the dilation, so I'm not able to actually find what the y-intercept should be, but remember we know the slope should be equal to negative 2/3, and if I look at choice 1, I find that the slope is equal to negative 2/3. So choice 1 is our answer here. If you were to solve any of the other ones, say choice 3, I would now have 2y equals negative 3x plus 5. That's just again moving the x term to the other side. Divide by 2 this time, so now I have y equals negative 3/2x plus 5/2. Negative 3/2 is not the same as negative 2/3, so choice 3 cannot be our choice. And you would find the same thing happening to each of the other choices, where the slope would not be negative 2/3. Number 23 says a circle with a radius of 5 was divided into 24 congruent sectors. The sectors were rearranged as shown in the diagram below. So again here this radius is 5. And it looks like they split it up and then they started rearranging. So we go from this picture to the next and to the next, where we end up with this rectangular shape, sort of a parallelogram, if you will. Where again, I know that this radius is 5. Our goal here is to find the value of x. Now if you think about x, it's a bunch of little curved surfaces. And remember that the curved surface comes from the outside of a circle. And so x is actually the circumference. But it's not the whole circumference, because the circumference is both the top and the bottom of this parallelogram here. So because I'm taking it and splitting it up into two different pieces, x is the circumference divided by 2. We can find the circumference. Circumference of a circle is always 2 pi r. So now I have 2 pi times 5, or in other words, 2 times 5 is 10 pi. And so now when I plug 10 pi in for the circumference, I have x equals 10 pi over 2. 10 divided by 2 is 5, so now I have 5 pi. And when we type that into the calculator, we get 15.708 blah blah blah. And because it says the nearest integer, that's a whole number. 15.7 tells me that we should round to 16. So our answer here is 16, choice 2. Number 24 says which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? So again, this is where we like to mark up circles, squares, clouds. A maps onto D, they're both in the same position. B maps onto E, and F and C should map onto one another. In order to prove triangles congruent, we have 5 options. Side, 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 angle, side, angle, side, angle, 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 side, and HL. But remember that HL is only used for right triangles. And we don't have a right triangle here, so we're going to get rid of HL. I'm going to work through each of these options to figure out what pieces of information they would give us. Remember that S means side, and A means angle. So here they say that AB is equal to DE. Sure, that's a true statement, so that's a side. And BC is equal to EF. BC is square to cloud. EF is again square to cloud, so that's another set of sides. But SS is not enough to prove triangles congruent, so I'm going to cancel that as a choice. Number 2 says angle D is congruent to angle A. Yep, they both have circles, so that's true. That's a set of angles. Angle B is congruent to angle E. They both have squares, so that's true. Another set of angles. Angle C is congruent to angle F. That's also true, but a third set of angles doesn't prove triangles congruent. AAA is not a method for proving triangles congruent. So that's gone. The next one says there is a sequence of rigid motions. Remember that rigid motions preserve distance. That map AB, the segment, onto DE, the segment. That's true, so that's a set of sides. BC gets mapped onto EF. The whole segment BC gets mapped onto the whole segment EF. So that means that they're congruent. That's another pair of sides. And AC, the segment, gets mapped onto DF, the segment. That's a third set of sides. So it looks like this could be our choice because side, side, side does in fact prove triangles congruent. But let's take a look at option 4. Sequence of rigid motions, again, preserve distance, that maps point A onto point D. Okay, that's true, but they're not being very specific here. Point A onto point D. And AB onto DE, both segments, so that's definitely a side. And angle B onto angle E, that's a set of angles. Here I have just SA, and this is because angle A doesn't necessarily have to be congruent to angle D. All they said was that A maps onto D. So sure, A now comes here, and AB is congruent to DE, so B definitely comes here, such that it's congruent to E. But angle A could be very wide or very small, not necessarily the measurement of D. Angle D, rather. So 4 cannot be our choice, which means we end up with choice 3. So again, answers for this page are number 22 is 1, 23 is 2, and 24 is 3. Number 25 is the first short answer question, and for number 25 you should be using a straight edge and a compass. And we're asked to construct an inscribed square in circle T as shown below. So here we have a square or a circle with T as the center. In order to construct the square, we need to first start by drawing in a diameter. Now, hopefully you do a better job than me. It needs to actually pass through T. So again, first step, draw diameter. Your second step is to construct the perpendicular bisector of the diameter. I don't have a compass on here on this program that I can use, but I'm going to draw the arcs as if I were constructing it. So I start by putting my center on this left point, my radius more than halfway, say here, and I swing an arc above and then back down below. Then I switch and put my center on the right side with the same radius, so it's approximately here, swing above, and below. Now again, mine's very messy. I don't have a compass, but you should make this nice and neat, keeping the radius the same the entire time. So now I need to connect through my intersection points. This should also be passing through T. I'm going to choose the point at which the circle meets my straight line to mark as a point for my square. So here, and again, circle meets the straight line here. My third step is to connect to make the square. So in order to do that, I'm connecting each point on the edge of the circle. So now we have a square inscribed in circle T.